Hello everyone and welcome to today's webinar on fitting high-tech capacitive HMIs into space-constrained form factors, jointly hosted by DigiKey and Texas Instruments. My name is Joe Bush and I'm the Managing Editor at Electronics Specifier, the provider of information resources to electronics and design engineers around the world, and I'll be your moderator for today's event. You'll shortly be hearing a brief introduction from Randall Ressel from DigiKey, after which we will hand over to our speakers Brian McCarthy and Sunil Oak from Texas Instruments, and they will commence today's webinar. The presentation will last for approximately 1 hour, after which we'll have time for a Q&A session, so please send in any questions you have during the course of the presentations, and we will endeavour to address them at the end. So without further ado, I will hand over to DigiKey for the introduction, and I hope everyone enjoys today's webinar. Thank you.
On behalf of Texas Instruments and DigiKey Electronics, welcome to our webinar. Thank you for spending the next hour with us. This information should be useful. DigiKey Electronics is the premier global distributor since no one has a larger selection of electronic components available for immediate shipment. We also have a world-class technical support team that is available 24/7 to help with your designs and questions. We are excited to partner with TI today as you learn more about their products. With that, let me hand you over to TI to start our webinar.
So hello everyone, this is Brian McCarthy with Texas Instruments. I'm the marketing director for our MSP430 microcontroller business inside TI, and I'm joined by Sunil Oak, who is one of our lead system engineers today. We're really excited about the topic that we're talking about, which is fitting high-tech capacitive human-machine interfaces into space-constrained form factors. So really looking forward to discussing the topic with you today and hopefully answering some good questions from you at the end of the session. If we look at the agenda for what we're going to cover today, we'll be starting to talk a little bit about the changes that we see in the industry when we look at HMI, and talk a little bit about the things that TI is doing to drive innovation in this area. And then I'm going to hand it over to Sunil, who will talk about some of the technical development challenges that we see and that we face every day as you look at fitting HMI into kind of space-constrained form factors. And then we'll wrap it up with how to get started from there. So as you look at the industry and kind of the different machines and devices that we interface with, if we think a few decades back, I think we can all kind of remember some of the different devices and things and look at what HMI kind of looked like to us a couple decades ago. But I think we also see that as the industry progresses, we're seeing a lot of advancements in HMI with these types of products. And here's just some examples. I mean, we're seeing, really much more sleek industrial form factors, HMI fitting into smaller spaces, really trying to come up with simpler designs to make things easy and convenient for people to use, but also very, once again, kind of sleek, attractive, and robust industrial designs. So there's some major trends in the industry where you see this type of change. Now, if we look at one of the key enabling technologies for this change, capacitive and proximity sensing is really a key thing that we see inside Texas Instruments, and we see industry-wide as one of the key enablers that's driving this change. If you look at this technology, really the reason these things are coming about is it's really helping move away from kind of clunky mechanical HMI type interfaces to much more simple, sleek designs that can be fit in many different form factors over many different mediums, whether it's glass, plastic, metal surfaces, all, like I said, all different shapes and sizes. And the nice thing with capacitive and proximity sensing, this technology helps drive things to much more reliable designs. You get rid of moving parts. You get your HMI design sealed, so you can work in harsh environments, whether you're in moisture sensitive or very dirty environments. It just gives a lot of flexibility when you're looking at HMI in general. Now, capacitive sensing isn't all that new from a technology standpoint. I'm sure many of the folks on the phone and on the webinar here today obviously have heard of capacitive type technology and being used in HMI applications. But at the same time, we don't see it in all the different products today. And part of the reason is there are some inherent barriers to the technology, and these are some of the things we want to talk about today. Now, if we look at some of those design challenges, one of the key issues that face customers and people as they go to do these types of designs, it's about reliability. Getting false triggers because of noise issues is a key challenge with capacitive designs, and that's something at Texas Instruments we're very heavily focused on. Having flexible designs that can be used in all different types of mediums, once again, is something that is often hard to come by. And then as you look at fitting HMI into portable applications, really finding those solutions that can do add that capability at the right type of power levels, also has been a challenge. And then doing that with the type of resolution you need for strong performance, and then having the right tools and to make things less complex and easy to use and easy to implement are all different challenges that have kind of been barriers. Now, once again, as we look inside TI at each of these different challenges, these are the areas that we've been investing in, from a technology and IP development front to make sure that we have solutions that address these different problems that we see in the industry. So we've released solutions with capacitive sensing that meet IEC 61000 noise certification. We've got single SoC solutions that can be used for a wide variety of applications, whether it's from proximity to capacitive sensing for metal touch, glass, glove-friendly industrial type applications. And we've done this in the world's lowest power, integrated microcontroller with capacitive sensing. And then later on in the presentation, Sunil's going to talk a little bit about the different tools and everything that we've put in place to also kind of ease the development process so that you can get started quickly. Now, the initial solutions that TI has developed for capacitive sensing have been out in the market for some time now. But as we go into 2017, we continue to drive different innovations, and that's what I wanted to talk a little bit about today. And here are just a few examples of some of the innovations that you're going to see from a capacitive sensing standpoint from Texas Instruments. Earlier this year at Embedded World, we demonstrated capacitive sensing in a very moisture-sensitive type application. This is kind of an E-lock or an access panel that could be used in an outdoor environment, with waterfall type conditions. Here we're showing the noise immunity and robustness that we built in with the technology. And we've also combined that with our connectivity solutions from our SimpleLink wireless business. A little bit later this quarter, we're also going to be releasing some design application notes around integrating capacitive touch through an ITO layer on LCD screen. So look out for that information coming later from TI. And then we also have our capacitive touch through metal evaluation module that's going to be available later this quarter. So these are some of the different innovations that we continue to drive this year. And today, the primary innovation we wanted to focus on is once again fitting HMI into small form factors. And what we've done is we've just released to market the industry's lowest power, smallest form factor capacitive touch solution. So this is the new, once again, smallest form factor capacitive touch solution that we just released from Texas Instruments. We call the technology Captivate inside TI, and this is our DSBGA package, so die size BGA. So what we just released is this capacitive touch technology that can support up to 16 buttons, and you can use various configurations of buttons, sliders, wheels, and proximity detection as well, as I mentioned before. This is in a 24-pin package with a 0.4 millimeter pitch solution. And you can see from a form factor standpoint, we're 2.3 by 2.3 and also very, very thin at 0.625 millimeter size. So when we talk about small form factor, not only are we talking about small form factor in 2 dimensions, but also in the 3-dimensional space as well. If you're challenged with having to design very thin form factor designs as well. If you look at some of the potential applications, I think we can all imagine the different types of electronics and such that we interface with today. And there's a wide variety of applications out there that are demanding smaller and smaller form factors. In some cases, the demand could be for very small sensor type solutions where you have very little space for your sensor design. And in other cases, it might be as simple as you just have very small PCB designs that have to fit into smaller form factors. If we look at some examples here, things like small power tools and appliances, small personal electronic devices. We look at things like nano drones coming out, and then even in more of the industrial segments, small form factor sensor designs, pneumatic sensor designs and such, where you need to add, some HMI. Overall, we're seeing a lot of demand in the industry, for fitting into small form factors, and that's why we've been investing in this technology. Now I'm going to turn it over at this point over to Sunil, and he's going to talk to you a little bit more in technical detail about the development experience and some of the different design challenges that are associated with doing these small form factor designs.
Thank you, Brian, and hello everyone. Thanks for being here. Brian introduced some typical products that can benefit immensely by having a CapTouch MCU in a teeny tiny die-sized BGA package. As part of the development experience, I will discuss some interesting design challenges when working on small form factor designs and some ideas on how to address them. Then we will look at a couple of design examples that we have created at TI, followed by a video of one of those designs in action. Some typical design challenges with small form factor designs are reliability, versatility or flexibility, power consumption, and complexity. We need to be able to reliably detect a touch and conversely not detect a touch when there is a presence of noise. The designer must have the flexibility to choose between a self-capacitance and mutual capacitance sensor nodes or design a suitable mix of these as per the product requirement. Low power consumption is essential as most of these applications are expected to be battery powered. And finally, the complexity of tuning the sensors needs to be easily manageable. Now let's address each of these challenges briefly. So what can we do to reliably detect or not detect a touch? The obvious mechanical construction guidelines would be to reduce the thickness of the top overlay and to minimize the air gap. This would serve to increase the sensitivity to detect the touch. Decoupling the electrically grounded enclosure from the sensor would also help improve immunity to noise. Let us see what the Captivate IP and the available software library provides to help with tuning the sensitivity of the sensor. All the options supported by the Captivate software library are configurable via a GUI called the Captivate Design Center. For example, there's an algorithm called the Dynamic Threshold Adjustment, which allows you to maintain a consistent level of sensitivity of the sensor while there is a presence of noise. So if you have a lot of noise on your system created by other components on the PCB, you can model that, you can measure that, and then you can tune your thresholds to maintain a consistent level of sensitivity. So on the flip side of increasing sensitivity, how do you prevent false detection of touch when an adjacent button is touched, for example? The best way is to keep a safe distance from the sensors and keep a safe distance between the sensors and sensor traces by mechanical constructions. The Captivate software library also provides a way to help with this. There's a concept of dominant button identification, which provides some level of nearby button rejection. So I've already gone through the dynamic threshold adjustment algorithm. There's also routine called multi-frequency processing, or MFP, which causes each sensor node to be measured at 4 different conversion frequencies. This raw data is then actually used to actually record a noise level and an observed sensor level that can be used to compare against the set threshold. For flexibility or versatility, flexibility in choosing self-capacitance and or mutual capacitance sensors is supported by the Captivate IP on this MCU, also in the die-size BGA package. There is support for up to 8 self-capacitance channels and up to 16 mutual capacitance channels. A single mutual capacitance button is shown here as an example. The size is 7 millimeters by 3.5 millimeters, and it is built using this MCU in the die-size BGA package. For power consumption, the Captivate IP provides features like wake on proximity or wake on touch features. So the part can be in a low power mode state. Low power mode 3 is what we call it, LPM3, and it can wake up the CPU and the main subsystem when it detects either proximity or touch. Coming to the complexity of tuning a sensor, the constraints of small form factor design make ideal sensor tuning difficult. But the Captivate Design Center is specifically designed to help with live or real-time tuning of the sensor performance. It can be used to configure and optimize different connections to the sensor from the MCU. So you can actually reassign which pin is being used to connect to the sensor, and then make the appropriate changes to the board. So you can view detailed sensor data, evaluate signal to noise ratio measurements, and tune sensor proximity and touch thresholds for optimum performance. And a little bit about the ball map. The die-size BGA ball map has been designed to make a single layer routing of sensor traces easy. So you can see the boxes show all the terminals that are actually used for connections to the Captivate channels. So we have seen some means of addressing the challenges of reliability, flexibility, power consumption, and complexity in typical small form factor designs. Let me show you a couple of examples we did at TI using the die-size BGA package. So this is showing a single mutual capacitance button implemented on a 7 millimeters by 3.5 millimeters 4-layer PCB of 0.5 mm thickness. You can actually show the bottom side as well, and it's as compared to a penny. You can imagine the actual size of it. The transmit and the receive lines are routed on separate PCB layers to improve touch detection sensitivity. That's one of the guidelines for mutual capacitance. Here's a little bit more elaborate design showing 3 mutual capacitance buttons, 1 mutual capacitance slider, and 2 self-capacitance buttons. The PCB is actually 75 millimeters long by 3 millimeters wide, and it's a 4-layer board again with a thickness of 0.5 mm. So let's see a short video of this board in action. Each button and slider is turned on and off in order. So it's a very quick and short demonstration. Now Brian will go over some of the tools that you can use to get started with your capacitive sensing product design today. Brian? All
right, thanks a lot, Sunil. So yeah, so I think as you, as Sunil kind of covered there quickly for us, there's a lot of different design challenges when looking at doing capacitive sensing HMI designs, and specifically when you get into doing designs that really need to fit in space-constrained applications. Obviously, today we did a kind of a quick overview of some of the key areas that you need to kind of consider when looking at your design, whether it is reliability and sensitivity to noise, the versatility, low power, the different complexities of design, obviously the layout and routing. The interesting thing with capacitive sensing type designs is there's definitely an electrical component, which at Texas Instruments we've done a lot of work to build the right tools and software into our microcontroller solutions to help enable engineers to do these complex HMI designs. But there's also a big mechanical component, and that's definitely where our teams and our engineers on both the applications and system side, such as Sunil, has spent a lot of time doing a lot of the hardware and mechanical designs to prove out these use cases with really small sensors and really small PCB designs. So hopefully that gives you guys a good overview of what we're announcing today, and then that the small form factor DSP-GA. If we look at getting started, as I mentioned, we are now in full production with this product. As I mentioned earlier, we call the technology Captivate inside TI. The DSP-GA product is listed here, the FR2633 IYQWR. Once again, if we look at the feature sets that this part offers, it is a fully programmable MSP430 MCU core. And what we've done is we've integrated that capacitive touch or capacitive sensing peripheral inside the device. We've really focused to continue on the ultra-low power front. So if you're looking at HMI designs for portable applications, once again, and oftentimes small form factor oftentimes equals portable. Less than 4 microamp wake on touch type capability with this device. And then, support for both, kind of self and mutual capacitance type solutions. I mentioned a little bit about the target applications. Ultimately, there's a very wide range of applications that this can be used for. And the interesting thing about capacitive sensing and adding these HMI solutions is that really the sky's the limit on kind of where your engineering, your teams can kind of take this technology. And I think what we're finding more and more is we're finding electrical and HMI solutions being added to more and more applications every day that historically, may not have had, any HMI in there. May have been just more mechanical type solutions. And now we're able to add functionality by putting solutions like this in those applications. We've been, building a very strong library of tools and collateral. You'll be, I'll point to you here in a really quick where on the web you can go find a lot of this collateral, but we've got development kits, software libraries to get started. The Captivate technology guide goes into a lot of details, both from an electrical and mechanical standpoint of layout considerations for your different designs. And then you'll see a number of different white papers coming out as well around these small form factor use cases. So keep an eye out for those as well. We've tried to make it very simple for our customers and for engineers to get more information about these capacitive sensing and about this Captivate technology. If you simply go to ti.com/Captivate, a very simple interface here where you can click on Learn, Develop, and Buy. The Learn portal is going to take you to a bunch of videos and training and collateral. Develop will take you to a lot of the tools like the GUI that Sunil talked about, our Captivate Design Center, and then obviously getting started if you want to buy samples and purchase development kits as well. We make it pretty simple for you there. This is just a quick snapshot on this next slide of the types of collateral that you'll find out on our Captivate web portal. Sunil showed you a short video of our small form factor DSP-GA design. We've got a bunch of other videos out there from showing you a number of different designs to the out-of-box experience to get started. And you'll also find more form factor reference designs. You'll see some other applications out here, whether it's doing a simple kind of remote control type function, touch through glass for more industrial and hazardous type explosion-proof environments is another key application space for us, and really a wide range of different applications that you can use this device for, once again, from a flexibility perspective. So lots of collateral out there for you to get started and learn more about this technology. Probably the most important piece of collateral we have is our Captivate development kit. And if you go out to the web, you should be able to find this quickly and easily. This is the part number for our Captivate development kit, and you can see a little picture here in the lower right-hand corner. When you buy this kit, it's typically a $99 kit off the web. And you get multiple boards that's included with this kit, and you quickly download the development center, the Captivate Design GUI, and you can be off and running very quickly and developing with this technology. Now, the exciting thing today is, as we kind of wrap up the presentation portion of the webinar, is that we're actually going to be running a promotion here for all the folks that have been able to attend today. And we're going to give 50% off this development kit for Captivate. And we're going to do it for the first 50 folks who are able to kind of come in here. The link below, right through our partners at DigiKey, down here, DigiKey/MSP430. You can go out there and request your development kit at the 50% off discount. So that's a quick overview of what we're announcing today, the HMI and very small form factors with capacitive sensing technology. We really appreciate the opportunity and look forward to answering any questions you might have.
Okay, thank you, Brian, and thank you, Sunil. In terms of questions, there was one that cropped up at the beginning of the presentation. You mentioned some of the applications for the DSBGA Captivate, and you mentioned that it could be used for moisture resistant applications. Would that apply to more rugged applications that could be subject to things like salt spray or so on oil rigs, for example?
Yeah, no, very good question. And yeah, we spent a lot of time working on kind of moisture resistant and basically HMI applications that are outdoor, whether it's E-lock type applications for door locks that are outside, or irrigation systems, or rugged oil rig type considerations and stuff. And yeah, definitely one of the key challenges there is developing solutions where kind of the salinity of the moisture or whatever that you may be dealing with, can change drastically and such. And the nice thing, we've done some work here. We'd be glad to have if someone has more interest in getting into more technical details on that, we'd love to talk to you about it. We have done different designs, testing with salt water. And the nice thing is with the development GUI, you can kind of fine tune the sensitivity and kind of tweak your application to be able to, work in those types of applications. And the other, using approaches like building guard bands around the keypad and stuff, there's a lot of different techniques that you can use to really build robust solutions that can work in, standard freshwater environments and or saltwater environments as well. Sunil, I don't know if you would add any other specific details to that.
I think that was a good answer as well, and like Brian said, that we have been conducting our own tests as well to see what other ways we can improve, what other ways in the ways that we design the sensor itself, that we can actually improve the sensitivity and the actual reliability of the detection. So that's those efforts are ongoing even within TI. So we can keep coming out with new reference designs to help with these solutions.
And would the same apply to applications that could be subject to high temperatures? So can it be tailored in the same way as it would be for a high moisture content application? Would the same apply to heat?
Yeah, I think when you look at temperature, so the devices that we're developing here, the solutions from TI that we call Captivate, they can range and support temperatures from -40 to 85 C. So from an IC standpoint, I think, definitely they're, more robust kind of temperature environments is really not a problem. I think from a semiconductor standpoint, the temperature ratings often far exceed, what you typically find in human machine interface, because human beings aren't going to be often interfacing to devices in the 85 type C type range, right? Because it's for obvious reasons. So but I definitely think in these robust environments. But I think the other challenge that I would see that's probably more prevalent is more so than heat is really industrial environments where you have individuals interfacing to machines that either have, in situations where people have thick gloves on, or they're very dirty environments with, kind of dirt buildup and those types of things where typical other solutions like IR or other solutions where you're relying on optical or light, or even mechanical from a reliability standpoint. Mechanical buttons may freeze up over time or lock up over time as dirt and those things start to build up. The nice thing with capacitive sensing is you can build solutions that you can work with glove-friendly environments, or if there's even dirt buildup or those types of things, you're still doing an electrical type sensing for capacitance, and not relying on something like an IR reflection or something like that for detection. So I would say that's where a lot of this technology really brings a lot of benefits in the robust area. But from a temperature standpoint, we support that as well.
Yeah, we've got another question come in, and that is, two really. What would be the thickness of the front glass, and is there any opportunities to work with plastics? Yeah,
and that's for sure. So from a plastic one, like if you order the TI Captivate kit, you'll see demonstrations through plastic. No question, we work through plastic. From a glass standpoint, we've done designs up to 60 millimeter thick glass. So there's many applications in the industrial space where engineers are building, say, like explosion-proof environments. These are some areas where, like I said, IR reflection may have been the use case or the solution in the past. But now people are finding that the capacitive solution is really the way to go, from an overall system robustness, even just overall performance. So the development kit that we showed a little bit earlier is actually a 10 millimeter thick glass. So if you go to TI.com and search for that touch-through glass TI design, that one is 10 millimeters, but we've also done designs that are up to 60 millimeters. So it's definitely can be used for thick glass type applications. And you'll see that we're also doing touch on glass through ITO for like on an LCD screen. We've got solutions for touch through plastic. We're working on solutions on touch through wood, metal. Pretty much you think of it. There's capacitive sensing is very flexible, and TI is working on solutions for that type of medium.
Okay. We have no further questions for the time being, but any of our listeners who do have any further questions, if you feel free to contact me at joe.bush@electronicsspecifier.com, and I will forward them on to Brian, and so I will endeavour to get them answered for you. We do actually have, as I was talking, there was another question that popped in actually, and that is, can this have an IoT connection?
Yeah, for sure. Another great question. So one of the things we're doing is we're working very closely with our connectivity team. So we have solutions today. If I do a quick jump back to the beginning of the presentation, if that's okay to do,
On behalf of Texas Instruments and DigiKey Electronics,
yeah, we definitely have solutions. The waterfall demo, if you actually look for that inside TI, is a solution that we use along with our BLE, SimpleLink BLE type solution. So we're definitely developing total solutions that show our capacitive touch with connectivity for IoT applications. So this one, for example, is the moisture rejection demonstration along with the SimpleLink wireless connection. And we're developing more and more solutions. Pretty much, I'd say a wide or a high percentage of our new designs do focus on adding that connectivity component. So I think that's kind of the key thing that we're doing inside TI with our MSP430 solutions, really looking at kind of the sensing and measurement aspect where the capacitive sensing is that component, and then working with our SimpleLink connectivity, really we can combine that end-to-end solution where you do the sensing and you're able to upload the data, up to the cloud through with these IoT solutions. So that definitely is a focus for us.
Another question that I think may have been answered to a degree in our previous conversations is that one of our listeners says that their requirements are HMIs for car wash controls, water spray, wash down, and cleaning. So presumably those sort of applications would also be suitable for Captivate.
Yeah, so definitely. I think for those moisture type applications, Captivate is a great solution. Joe, did you say specifically for automotive type applications? Was that the question, or?
Well, car wash controls were mentioned, yes.
Okay, car wash controls. Yeah, so I think for the moisture applications for sure. The one thing I'll just clarify for people today, the Captivate solution isn't Q100 certified. So if you had a Q100 requirement, TI does have some other solutions, like from our we call the FDC capacitive sensing solutions for Q100. So there's kind of a wide range of capacitive sensing solutions, whether you need the full automotive qualification or if it's not a requirement to have the full Q100. Then a solution like the one we're showing here in the small form factor could also be used. So really the DSPGA is really targeted at a lot of these industrial type applications, and but very similar from a kind of moisture sensitivity and perspective.
Okay, thank you, Brian. I think that does end the questions that we have. But just to reiterate, if anyone does have any further questions after the webinar finishes, then please feel free to contact me. But if that is it, guys, I think that will conclude today's webinar. Thank you for everyone for attending and listening, and thank you to the two presenters, Brian and Sunil.
And Joe, but I just want to give one last kind of plug, trying to move the slide there. But for everybody, please don't forget about the promotion there. Would love to support you with the discounted kits and everything and get you started. And definitely, if you have any questions, please reach out to us, and we'd love to talk to you more about your HMI designs.
Thanks, Brian, and thank you, everyone else.
Thank you.
Thank you, guys. Bye.
Bye.